Good morning, friend. Today we will discuss the working of solar power plant. Sunlight is composed of photons or bundle of radiant energy. When photons strike a PV cell, they may be reflected or absorbed, transmitted through the cell. Only the absorbed photons generate electricity. When the protons are absorbed, the energy of protons is transferred to electron in the atom of solar cell. Uh, Solar cells are usually made of two thin pieces of silicon, the substance that make up sand and second most common substance on earth. One piece of silicon has a small amount of boron added to it, which give it a tendency to attack electron. It is called a p layer because its positive energy. The other piece of silicon has a small amount of phosphorus added to it, giving it an excess of free electron. This is called n layer because it has tendency to give up negatively charged electron. The figure shows working of photovoltaic cell. Photoelectric effect basis process by which a photovoltaic cell convert absorb sunlight into electricity. Proton nodes knock electron free from the silicon structure, freeing them to enter electric current and power a load. Physics of photovoltaic generation. N-type semiconductor, diffraction zone, P-type semiconductor. PV array, cell module array, PV cell modules arrays, PV system component, solar array, battery, charge controller, DC load, inverter, AC load, photovoltaic cell. Here we can show figure of photovoltaic cell, PV applications. Industrial high temperature solar thermal power plant. In this figure, we have shown industrial high temperature solar thermal power plant. Definition: industrial high temperature solar thermal power plant are systems for industrial scale use only that utilize solar heat energy to power a turbine in order to produce electricity. Main goal: to successfully provide a fuel that is clean, efficient, cost effective, energy use specifically for industrial scale users. How does it work? 5 types of with different models, all operated somewhat alike, use lens and reflectors to concentrate solar power. Heat drives thermal power plant. What happens at night? Power is stored during the daytime in molten salt at approximately 1050 Fahrenheit. Salt sometimes used to heat graphite, which would be used as a heat storage medium. Nighttime operations are possible. Storage of heat from solar power plant can allow solar power plant to operate around the clock. Unique because they can generate power when it is needed, day or night, rain or shine. Design: solar power tower, parabolic trough, solar dish, concentrating solar power plant, Fresnel reflectors. Comparison of major solar thermal technologies. Applications: tower dish trough, Application: grid connected electric plant, process heat for industrial use. Parabolic dish, stand alone small power system grid support. Parabolic trough, grid connected electric plants process heat for industrial use. Advantage: dispatchable base load efficiency, high conversion, efficiency energy storage, hybrid operation. Dispatchable electricity, high conversion efficiency, modularity, hybrid operation. Dispatchable peaking electricity, commercially available with 4500 GWh operating experience, hybrid operation. High temperature system. A receiver is mounted on the tower which is 100 to 50 meter high. Reflecting mirrors are known as heliostat. The heliostat are arranged in such way that they direct the solar energy on the receiver throughout the day. The receiver is designed and positioned in such way to intercept, absorb and transfer maximum heat to working fluid. The temperature achieved is 1500 degree to 1700 degree. Power tower, solar 1 CA, steam heat transfer 10 megawatt, solar 2 molten salt heat transfer 10 megawatt, solar trace molten salt heat transfer 15 megawatt. Power towers. The first large-scale solar energy project in US in 1982. Solar plant with a field of computerized mirror called heliostat that follow the sun. Heliostat raised toward a center tower where heat is used to produce steam. Steam turn a turbine like in more traditional plant. Solar power tower. Solar power tower. Flat mirror are aimed to melt salt at the receiver target. Parabolic trough made a long rows of concentrating mirror only curve in one direction, track the sun from east to west with surface that focus sun energy. Heat transfer fluid run through pipe that is at the focus of the trough. Heat is transferred to working fluid, usually water, and used to power or drive turbine. Parabolic trough. Parabolic trough sunlight focus on heat transfer fluid which then runs steam turbine. Parabolic or concentrating character. The reflector will have parabolic shape so that the sun rays striking the profile will be reflected on the focal point. If a tube carrying a fluid is kept along the focal line, the fluid will be heated to a very high temperature. Figure shows solar power plant. Low temperature system. This system uses a flat plate collector which can heat water up to about 80 degree only. Water is circulated through the flat plate collector. Heat exchanger is used to vaporize the low boiling fluid and the butane vapor will run the turbine. Parabolic trough generating plant. Parabolic dish engine system. Still under development, consisting of parabolic shape concentrator that tracks sun in two axes. Cycle heat engine mounted on receiver generate electricity or sunlight heat fluid that is transmitted to a center engine. Concentrating solar power. Solar concentration. This 20 kilowatt solar system dishes Diop visitor in Alice Spring, Australia. The concentrator uses an array of mirrors to focus sunlight onto high efficiency solar cell. Four support hold the cell in front of the mirrors. The support also supply cooling water and electrical connection. Large scale PV power plant. Political economic obstacle. Currently not economical. High cost of building facility needed. Currently can only lengthen the amount of time you have energy by a few hours. Would require more high voltage DC lines to carry the electricity. Funding will be needed to bring solar thermal electric into large scale development. Political economic opportunity can create 2.5 times as many skilled high paying jobs as a conventional power plant that use fossil fuel. Moderate net energy, moderate environmental impact, cost reduced with natural gas turbine backup. Technological obstacles need backup to storage system. Storage. The solar thermal plant would needed just 16 hours of storage to continuously generate electricity. Low efficiency. Increasing efficiency by 20 to 30% could significantly reduce the cost of in electricity. Technological breakthrough. Future solar collector will be mass produced using lower cost flat mirror rather than curve through and seed low to the ground reducing wind load. Fast construction. Land use issue takes a lot of area require high land use work based in desert or other areas with lost option. Negative environmental impact may disturb desert areas, could potentially endanger wildlife, take up at least 9 square miles of space. Positive environmental impact. NO CO2 emission, reduce air pollution, less use of fossil fuel. Advantage of solar energy, clean, sustainable, free, provide electricity to remote places. Disadvantage of solar energy, less efficient and costly equipment, part-time labor depend on location. Environmental impact of PV cell production. Today we will we have stopped here. After that, tomorrow we will discuss tidal energy. Thank you.